Hi everyone, my name is Jinbo Ma. Today I'm going to show you my presentation. My presentation name is Stress Detection Using Wearable Devices Data. This is my final presentation, and my major is Machine Learning and Data Science. So the first one, I'm going to the motivation. The first one, I'm going to say the why stress detection metrics. As we all know, the stress infection, both physical and mental health. So it can be, if we have stress, it can be make our body have a lot of problem like heart disease, anxiety, or something else over here. So most people don't realize they are stressed until it's too late. So I think if we can find our stress or problem too earlier, we can stop this to happen in our body. So this is a big problem. So why I choose the wearable devices? Because as we all know, the wearable devices is pretty easy to use. As we all know that for example, we can use the Apple Watch to collect many of the signal from our body. So it's very easy to use, and it can also collection a lot of our body signature, and so it can not only collection the signal from the lab, it can also collect the signal from our real life. So this is good point. So my goal is used to machine learning to detect the stress earlier from the variable data. So then I'm gonna make the system fast, light, and easy to understand. So next is related work. As we as we know, there is a lot of related work from my research. There have the same research before of me. So the first one is there have a lot have a complex mission they use like the deep learning. They are use the mission include the CNN and LSTM over here. And actually, for the interpretally, they're hard to explain, and they actually gonna use a lot of data sets. They're gonna use a large data set needed. And if you wanna use the deep learning module over here, you have to have the GPU or cloud over here. It means you're gonna have a big devices or supercomputer over here. It's very complex or hard to use it. And for the output, they just have the stress or no stress. So it's not gonna show you what's your emotional right now, what's your exactly emotional right now. So I think for this one, I can make it for better. So for me, I'm gonna use the machine learning module, which is I'm gonna use the SVM and random forest over here. For me, I think this is pretty easy to interpret, and it can also work with smaller data, smaller than the deep learning module over here. And it actually can run it on laptop or wearable devices. It's pretty easy to use. You can just have a laptop or wearable devices like Apple Watch. You can easy to use it to run its system. So I'm gonna like separate the separate output with for emotional classic supported. I'm gonna show you which four I'm gonna use in the next slide. So the problem and objective. So there also have some problem over here. So the problem is how can we detect the stress accuracy using wearable devices? Like the stresses is hard to detect earlier, and wearable devices can help, but many systems are too complex. And current emission is hard to understand and need to strong computers over here. So for right now, it's this problem over here. So my project goal is to build a simple and clear system to detect the stress, and they're gonna using data from variable body to sensors. I'm gonna classify the four states like the baseline, stress, amusement, and meditation over here. I'm gonna use two kind of the machine learning module, which is a random forester and SVM over here. So my final goal is make sure the system works well and can run on mobile or wearable devices. So the dataset I choose is WSAD. So this is I found from the UCI website. So the full name is Variable Stress and Effect Detection. The participation is there have 15 objectives over here. So the sensor shield is Raspbian Professional, which is a JSROM devices over here. I already show you how the Raspbian Professional work over here. So they put a lot of stuff in your body and they're gonna collection the your body signal like the EMG, ECG over here. This very clear over this picture. And the physical signature collector is gonna collect like the ECG, EDA, EMG, temperature, or SEP or the accelerometer. Yeah, accelerometer. So they're gonna have the collection this kind of six signal over here. And they're gonna select the four emotional states from this the dataset, which is a baseline, stress, amusement, and meditation. Next, I'm going to the methodology. So this is my flow chart over here. The first one is I'm gonna the collection raw data from the variable scene sensors. So the first one is collection data, and the second one is proposed data like cleaning and normalization. And the next, I'm gonna to the extract the key feature like the heart rate, EDA, or something else over here. And next, I'm gonna train kind of the two modules, which I said before is SVM and RF, which is random forester. And the step five is gonna go into the output. So this is my work chart over here. And the feature engineering. So for this one, I'm gonna separate two kind of the station, which is the data set, which is training and test. For the training, I'm going to use the 80%, and for the testing, I'm going to use the 20% of the data. So this one I'm gonna do the matrix like I'm gonna show you like the accuracy, and the next I'm gonna I'm gonna have a bar chart which I have a three since which is perception, recall, and F1 score is gonna show you like the show in the bar chart in the bar chart in the next slide. So I'm gonna give you kind of the confusion matrix over here. So for this is all of that is for evaluation. I use kind of this multiple metrics over here. I think it's I think I use this one. It can also set up ensure and the module test fair and the performance is mentioned in detail. So I think this way is pretty good over here. And for this one, I also show you how I separate the training and the test in my code over here. And the next is result. The first one I'm going to show you the accuracy bar chart. As we can easily to see, the first two is the SVM and the last two is a random forester. We can easily to say the SVM is around the 96% and the random forester is almost 100%, which means the random forester is pretty strong over here. And the SVM is also good over here, but it's it's not pretty. Yeah, as you know, yeah, it's not pretty good, but it's already did very well over here. So this result shows that the classification modules can be still powerful when the data cleaning and will propose. Next, I'm going to show you like the classic performance. So on this slide, I have the kind of the file picture over here. This tool is show you the SVM SVM data test data and training data. This tool is show you random forest test data and training data. So as we can see, this show hours of the for SVN, this is just have a little bad in the baseline because the baseline, as you can see, the precision, recall, and F1 score in the F1 is not very high over here. And as we can see, the amusement is pretty good for the SVN. And actually, I think stress is also good over here, but meditation looks not good. Next, we're gonna move to the random forester. As we can see, all of for this kind of emotional state. So the random forester looks pretty good, almost 100% in this kind of three things over here. It looks pretty good. And for the recall compression per classes, we can easy to see that one. So for the random forester looks all good in everything over here. But as we can see, for the SVM, the meditation, amusement, and stress is pretty good. But for the baseline, it looks not good. Yeah. So from this page, we can easily see the random forester is more stable. It's more stable and performance better, curious, stable, emotional bonds, especially when states have similar physical signals. And the next is a confusion matrix. As we can see, there have four picture over here. The first two is SVM, then the last two is random forester. So as we can see, so for the random forester, there have 146 baseline predicted on stress. We have 19 baseline predicted on amusement and 285 baseline predicted on meditation. So but another one looks really good. There's also just have a 5 amusement predicted on stress. So it means it's just baseline have some problem. It's also happened in same thing in the test data. Yeah, always the like same situation over here. As and next we're going to the random forester. Looks all good. Just for the test one, there's only one stress predicted on the baseline. So as we can easily say, the random forester is more robust. The random forester is pretty strong over here. And for the discussion, so here So for the discussion, I think the random forester did better than SVM in all tests. That's easy to say. That's what I show you in my result. It's easy to say that result. Yeah. So the SVM made more mistake on the similar classes like the baseline and the meditation over here. Yeah, it is same things. And I also learned that the simple machine learning still works well if the data is cleaning, and even without the deep learning, I got a good result using a module that are easy to understand over here. Yeah, and the whole system is small and fast, which makes it good to phone or wearable devices that need to real-time stress detection. And there have just one problem over here. There's one limitation over here. All of that signal we collection from the lab, but actually not from the real world or life use. So I think the next level is we're gonna should be solve this limitation for collection a lot of the signal from our normal life. For the conclusion, to summarize, I built a kind of the simple and effect machine learning system, and it finds the different emotional states by using signal from wearable devices. So as we know, the random forest module works the best. It would be the even tail apart and the cases like the baseline meditation. So the system is easy to understand and works well and can run in phone and or wearable devices over here. So and I test kind of for emotional state. It reached a high accuracy and recall. This shows the classic machine learning still works great if the data is clean. If the data is clean, and the project gives our like strong baseball feature stress detection tools. So these tools can be used in real life, I think. So they are easy to explain and did not use, and didn't need a lot of like the computation power. We don't need to we don't need to like the very big devices over here. So thank you for your listening. This is my final presentation over here.